Factoring a quadratic trinomial when our a value does not equal 1. Just remember that our a value is the coefficient of our x squared term. It's just the number attached right there. So if you look at your first example, 2x squared plus 3x minus 9, I want you to remember to always check for a greatest common factor first. It doesn't matter what kind of factoring we're doing, we always check for a GCF first. All right, so I look here, 2x squared plus 3x minus 9, and they don't have any numeric values or variables in common, that all three of them don't, so that it does not have a GCF. But I want to see if I can break this down into binomial factors. So I'm going to set up two sets of parentheses right here, and then I am going to create a t-chart. And this method that we're using right now is called the swing method. So in the other video that was posted, we did the guess and check method. This is the swing method. So the swing method, the first thing that we're going to do is multiply our a value times our c value, a times c, which in this case gives us a negative 18. And then in the right column, we're going to place our b value. What values add to make b? And our b value is the number 3. So let's list out the factors of negative 18. We have negative 1 times 18, or positive 1 times negative 18. We can do negative 2 times 9, or positive 2 times negative 9. We also have negative 3 times 6, or we can do positive 3 times negative 6. Those are all of the factors of negative 18. Now let's see what those values add to make. If I have negative 1 plus 18, that only gives us a 17. And that's definitely not what we wanted. We wanted them to add to make 3. So this is not the pair that I want to use. Well, if I did positive 1 plus negative 18, that gives us a negative 17. Same number, opposite sign as our first pair, also wrong. So if you scan through this list, hopefully you see that a negative 3 and a positive 6, so negative 3 plus 6, gives us the positive 3 that we wanted. So that is the pair we are going to use. In our set of parentheses, these are where my binomial factors are going to go. The very first thing that we put in each of these parentheses is our variable. So we're going to start with an x in each of them, and then we are going to place our factors. And it doesn't matter what order we put them in, so I'm just going to write a minus 3 here and then a plus 6 here because our 6 is positive. So that's the next step. Then we are going to look at our a value. It's the number 2. We are going to divide both of our factors by whatever that a value is. So we're dividing both of these by 2. And now let's see if we can reduce. If I have 3 divided by 2, that does not reduce any further, so that is just going to be x minus 3 over 2 for now. And then in our second set of parentheses, 6 divided by 2, it does reduce. It reduces to the whole number 3, x plus 3. Now we don't want to have any factors with fractions in them, so anytime you see a denominator, we are going to swing it to the front. So this 2 that's my denominator swings to the front. And our binomial factors end up being 2x minus 3 times x plus 3. And that is how you factor using the swing method. All right, let's try another one. 8x squared plus 10x minus 3. Of course, we always check for a GCF first, and I notice that I have no greatest common factor in this problem again. So I am going to set up my binomial parentheses here. Make sure you leave enough room for 2 terms in each of them, 1, 2. And then we are going to create our t-chart. Remember, on the left side, it's a times c, so 8 times negative 3, which gives us negative 24. And then our b term, which gives us a positive 10. What adds to make b? And we want it to be a 10. So the factors of negative 24 that you can think of, there are a few. Let's say negative 2 times positive 12, or positive 2 times negative 12. And I'm going to stop right there. Those were the first things that popped into my head. And I say, oh, well, wait a second. negative 2 plus 12, that right there automatically gives me a 10. So that's what I wanted. I really don't need to find any other pairs. So if listing them all out first helps you, then do so. If you can kind of go through it in your head and quickly pick out the factors that combine to make the B value that you need, great. So we're going to start by placing our variable in the front of each set of parentheses, and then we are going to include our minus 2 and our plus 12, the two factors that we came up with. All right, then we check our A value, which is a positive 8. So I am going to place divided by 8 on both of these. The next step that we want to do is reduce our fractions. So x minus 2 divided by 8. 2 over 8 reduces to 1/4. And then we have in our second set of parentheses 12 over 8. 12 and 8 are both divisible by the number 4. So this ends up being x plus 3 over 2. And again, we don't want to leave any fractions in our binomial factors. So any denominator that we have is just going to swing to the front. So this 4 swings in front of our x. This 2 swings in front of our x. And these binomials are going to be 4x minus 1 times 2x plus 3. And that is how you factor a quadratic trinomial using the swing method. Now, if you want, you can go ahead and look at these steps right here. I have them written out for you. Go ahead and pause the video if you would like to and write these down to help you. You are going to make your t-chart, your A times C plus B first. Create two binomials using the factors that we found in step 1. Step 3 is going to be to divide both of those factors by your A value and reduce them. And then, of course, step 4 is you're just going to swing any denominators forward.